Hello guys, welcome to CaptainDuckDuck tutorial. Today I'm going to show you perhaps the easiest way you can set up a cluster of web servers that can run multiple apps without needing you to know Nginx, Apache, Docker, how to set up SSL certificates, and so on. CaptainDuckDuck automatically sets up all of these things for you and has a very simple interface. Before we start, please know that in the description below I have added some explanation to some questions that you might have during this video. Alright, let's get started. Okay, first we need a server to install Captain on it. I'll go to my DigitalOcean and purchase a $10 server. They charge by hours, so I can delete the server after this tutorial, and it'll cost me less than $1. I will also leave a referral link for you down in the description below, so you'll get a $10 credit for free once you sign up. One of the reasons that I like DigitalOcean is that they offer easy pre-installed app. I'll show you in a second what I mean. Alright, so I'll go here to my DigitalOcean account, and at the top right corner I click on create and I create a new droplet. Droplets in DigitalOcean terminology are servers. So I click on one-click apps, which is pre-installed app, and I select Docker. Remember, if your server provider doesn't have pre-installed app, you have to install Docker separately. For size, I'll go with $10 size, and I'll select New York, whatever their default is. And I don't care about these options, I'll leave it as default, and I select my SSH key. If you haven't added your SSH key, you have to add it yourself. By the way, I leave some more description in terms of SSH down below if you guys need more help with SSH. And I select a new name, I'll call it YouTube Overview 1, and I create the server. Okay, it takes about a minute. Alright, now that the server is created, I need to SSH into my server. I can simply grab the IP address of the server because I have added my SSH key to the server. I can go to terminal and I can SSH root at the IP address of the server. Alright, yes. Remember, Docker is pre-installed here. So I need to go to the GitHub account page of CaptainDuckDuck, and I'll grab this line. I'll copy it and I'll paste it here. It kicks off Captain installation and it'll take about like 30 seconds or so. I'll fast forward here. Okay, Captain installation is done. Captain is installed on your machine. Now you can go to the IP address colon 3000, which is available on the GitHub page. If you look here, so IP address of your server, and then the port is 3000. Yeah, enter. And there we go. We are now in Captain. Alright, this error means that the Captain is not ready yet. You refresh it. It takes about 20 seconds for Captain to comes up. Alright, so we're good. Awesome. Now let's get into Captain workflow. These are the things that we are going to review today. Domain setup. Deploying apps using web interface and command line tool, setting up instances, changing environment variables, and also setting up the cluster. Alright, let's go back to Captain and log in using the default password, Captain42. The next thing we do, we go to settings and we change our password. Alright. Okay, type in the new password here. Alright, let's log in using the new password. Awesome. The first step that we need to do is to connect our domain to Captain so we can access Captain using a clean URL and not the plain IP address. For this purpose, I go to GoDaddy, which is my domain provider, and I go to CaptainDuckDuck.com, which is my domain. Yours is going to be different. I'll go to the DNS settings and I'll add a new A record. And for the type, I click on A. For host, I'll do start.youtube. It has to be a wildcard for Captain, so start.something. In here I have start.youtube. In your case, you can be start.anything you want. And the .2 box is gonna be the IP address of our server, and TTL is 600 seconds, 10 minutes, and we'll save this. All right, now that we have added this row, anything.youtube.CaptainDuckDuck, again, it's going to be different for your domain, is going to resolve into my IP address here. So I type in youtube.CaptainDuckDuck.com as my root domain in the dashboard, and I click on update domain. If everything works fine, then my Captain gets updated and I can access Captain at this address here. Also note that during this tutorial, I'll get kicked out multiple times and I'll have to log back in. This is because Captain doesn't use cookies in order to reduce the security risk that they may cause. So every time you refresh your dashboard, you'll have to log back in again. Don't worry, this is normal. By the way, if verification fails, it means that your DNS setting haven't been propagated yet. So try again in a few minutes, it'll work then. And also keep in mind that it's a wildcard DNS setting, so it has to be start.something, right? Or star itself. Great. Okay, so the next step is to enable HTTPS. This is one of the great things about Captain. Typically, you have to pay hundreds of bucks to get your SSL certificate, but Captain uses Let's Encrypt to give you free SSL certificates, and it automatically renews them in the background, so you don't have to be worried about your SSL certificates getting expired. All you need to do is to enter your email address and click on update, and it takes a few seconds and it should refresh. Yes, it was successful, and you get redirected to the secure page. You log in again. Great, now HTTPS is enabled. The next step is to force HTTPS, which means redirecting all non-secure traffic to secure traffic. And it doesn't allow any non-secure traffic to go through. All right, we click on OK here. Now we are forced to use HTTPS. Great. Even if I manually try to go to HTTP site, it automatically redirects me to the secure version, HTTPS version of the website. All right, now that we are all set up, let's deploy some apps. Go to the apps section from the left side menu and create a new app. It'll take a few seconds the first time you want to create a new app. All right. Yeah, there we go. Our first app is created, and this is the address that Captain automatically assigned our app to. You can connect your custom domain, environmental variables, which we're gonna review later. Okay, if you click here, you'll see that your app is available here. Sometimes you'll see a 502 error. It means that your image haven't been fetched yet. Anyways, all these delays, they always apply to the first time you wanna pull an image. The next time after that, there is no delay. In fact, let me go back to the apps section and delete this app. All right, I need to type in the name. Okay, delete and create a new app. Okay, see how much faster it is? Okay, so one of the ways of deploying apps mainly for testing is the web interface. You can upload tar files of your app using this button here. For this demo, I used some sample apps from our GitHub page. I downloaded them here and I'm gonna upload them using this button. So there is a Node app, there is a PHP app, and there is a Python app. I'll go to the app setting, all right, and I click on this button and I'll upload the PHP one. All right, click here. It's gonna take about 30 seconds the first time you wanna upload something. Okay, it's gonna download Apache image, PHP compiler, and everything. There we go, our app is ready. Okay, now I can simply click on this link and I'll go to the PHP app. That's great. See how quick it was? I didn't have to install Apache PHP or anything. I'll upload the Python app now. And a very similar process. Okay, I'll fast forward the video. Nice. Okay, so our app is built, and if I click on this link now, instead of the PHP app, I am going to the Python app. Now here's the interesting bit. How does Captain know the other one was a PHP app, this one was a Python app? The secret is a file named Captain definition, and it sits at the root of your project. If you look at the sample project, this is the file. I'll open it. Okay, it's just a simple JSON with two values, schema version and template ID. Schema version is always 1, template ID is the programming language you use, /version. A list of template IDs and versions are available in the GitHub page, and note that the initial version of Captain has built-in support for Node, Python, and PHP. But it also supports Dockerfile instructions, which basically enables you to run any app, Java, Ruby, Scala, you name it. See our GitHub page for more details. All right, note that it has to sit at the root. So next to package.json for a Node project, next to index.php for a PHP project, and next to requirements.txt for the Python project. All right, let's get into real-world deployment. So this web upload was fun, but this is not how you should deploy apps in real world. Instead, you just install Captain command line tool by running this line and following the instruction. All right, I'll copy this line, assuming you have npm package manager installed. I'll add sudo because I'm running on Linux. All right, I'll enter my password and I'll wait. And great, Captain command line is installed. The next thing I need to do is to log into Captain, CaptainDuckDuck login, and I'll enter the root domain of Captain, which is captain.youtube.captainduckduck.com for this example. I'll paste that here and enter. I have HTTPS, yes, and I'll enter my Captain password. All right, this is just a random name, yeah. Okay, I am now logged in, great. The next thing is to deploy an app. So I'll go to the sample directory where I downloaded all these files, and I can untar one of the sample project. I'll pick the PHP project and I'll extract it here. I'll go to the directory, I'll open a terminal here, and let me grab the terminal, bring it over here. Okay, I'll do CaptainDuckDuck deploy. All right, I'll pick the server, which is captain.youtube.captainduckduck.com, master branch, and the app name that I want to deploy this repository to. The app name is YouTube-2. I'll copy that name. All right, I need to delete this bit. Okay. Yeah, enter yes, and enter. It's building the source code and it's done now. All right, now if I go to this link, I can see my PHP project again. Great. Note that this is a Git repo. So whenever you want to make a change and you want to deploy it, you have to make a commit. For example, let's open the index.php file here and make some changes to it. Yeah, let's add some exclamation marks here. All right, let's close this and save it. Yes. Now, if I do git status, I see that this is modified, but it hasn't been committed yet. So I'll add it and I'll make a commit. All right, now I can push it to the server. So I'll do CaptainDuckDuck, deploy again. I'll pick the server, branch, yes, YouTube 2, and yes, it's building the source code. Great, so if I go to the link here, yes, if I click here, I'll see the exclamation marks added. So after I made a commit, I pushed it to the server and the new changes were picked up by the server. For this step of tutorial, I'm gonna upload our Node.js sample app, which is a bit different from Python and PHP sample apps. I'm gonna explain the difference in a moment. First, let's go here and upload the app. Click on upload and select the node.tar and upload. So yeah, the main difference is that the sample Node.js app is not a static web page. It does three things. First, upon startup, it randomly picks up a name and caches that value in memory. So as long as the app is alive, that name remains consistent. But if you restart the app, it'll pick up a different name. Second thing is that it gets its public IP and prints it on the main page. Let's actually open this link here. We'll see it in the details. All right, so you see here, this is the random name that it picked up during startup, and this is the public IP. Also, the third thing is that it tries to pull a value from environmental variables. Of course, that environment variable is not available now, so the value is undefined. All right, let's first try assign a new environment variable. All right. So hello for value and save. Okay, Captain in background killed the previous instance and spun off a new instance. If I open this, you'll notice that the name is different, meaning that this is a new instance of the app, and the custom key has now a value attached to it. All right, let's say your app gets a lot of visitors and you want to increase the instance count of your app to 2, meaning that 2 instances of your app is running. All right, so this is 2. I'll go back here, I'll open this link, and you notice that every time I refresh the page, I'm gonna hit a different instance of the app. There are 2 instances of app running on the same machine. All right, notice that although it's very easy to set up more instances here, you're always bounded by the physical resources of your device. In fact, why don't we go to the monitoring tab here, and let's look at some basic information that's available here. Total requests, don't worry about this large number here. It's actually Captain doing its own health monitoring every couple of seconds, so don't worry that this is a high number. All right, this is active connections, and this is active request and waiting request. Anyway, so Captain uses net data which is an open source project for monitoring Linux distributions. So after you started it, you can see that it gives you a lot of settings for alerting. You can find more information on their GitHub page, but once you open this page, you'll see that it's got pretty much every single metric of your machine here graphed out. CPU, network, disk, RAM. And all right, let's close this page and reopen it again. One more interesting thing about this page is that it automatically binds to your Docker apps, which you define here, and it shows the RAM and CPU that they are consuming. So if you scroll down here, you'll see that you have srv-captain-YouTube2, which is your app, and you'll see that it's consuming about 30 megabytes of memory. Of course, 0 CPU because there's no request coming in. Same for the other instance of that app. And these are other containers that Captain spun off in order to maintain itself. This is the Captain itself, which is doing active work. It's monitoring its health. It's managing the containers. This is the certbot managing your HTTPS certificates. Okay, one more thing before we go to clustering. Go to your apps and you'll see that there is an enable HTTPS button here. You know how we enabled HTTPS for Captain itself? Now we can enable HTTPS for the app, each individual app. Now I enabled HTTPS for this app. It'll take a couple of seconds. When I click here, you'll see that it was previously a plain plain HTTP. And if I click here, I'll go to the secure version of that thing. And you can also attach a custom domain like www.something.com, which you own the domain for. I'm not going to go into the details. This is pretty straightforward. All right, let's talk about clustering now. Say your app is very popular and you'll need to create more instances of your app, but your server cannot handle any more instances. Now cluster comes in. You can attach an extra machine or maybe even hundreds of extra machines to create a cluster of web servers. Captain uses Docker under the hood to create instances of your app on multiple servers. When a request comes in, it automatically gets load balanced between your app instances, perhaps running on different nodes. You don't need to do anything. Routing and load balancing just happens automatically. Okay, so for setting up cluster, we first need to create a second server. Let's go back to DigitalOcean and create another droplet. Create droplet and select one-click apps, Docker again. I'll go with the same size, $10 one, and no changes here, no changes here. I'll add my SSH key again, and I'll name this one YouTube Overview 2. All right, create. And it's building, and now we have a second server. One more thing before we start, DigitalOcean sets up automatically firewalls for your server. These firewalls block some ports that are needed for Captain to work properly. Detailed firewall configuration is available on Captain's GitHub page, but for the purpose of this tutorial, I'm just going to disable firewall entirely. To do this, I will SSH into my server and disable firewall. All right, I'll copy the IP address of my second server. SSH root at the IP address. And I'll do UFW disable. This command UFW disable disables firewall completely for your Ubuntu server. All right, I'll close this and I'll go copy IP address of my first server. And all right, let's exit and SSH into the second one, which is our first server. And do the same thing, UFW disable. Great, now our firewalls are disabled. We can go to the next step. All right, now that our servers are ready, the very first thing I need to do is to start Docker Registry. Up until now, we didn't need this because all of our instances were sitting on the same machine. But now we are going to share builds between different servers. Captain gives you two options. The easiest option is self-hosted Docker Registry. All right, just click on this button here and wait a couple of seconds until Captain finishes installation of Docker Registry. All right, click on OK. Note that it actually takes about a minute for this to complete. So when you click on OK, you might see some errors. Wait for about 30 seconds to a minute and then refresh the page. Okay, now let's log back in. All right, we'll see that, yeah, the Captain Docker Registry is here. Great. Now that the registry is set up, I can go ahead and attach the second node. To do this, I need to go to the Nodes tab from the left side menu, click here, and I need to fill these fields here. All right, I'll go to my DigitalOcean and I'll copy the second server IP address. That's the remote IP address. I'll plug it in, okay. The first server, which is our leader node. For node type, I'm gonna select worker. You can read more about worker and manager on our GitHub page. And I'm gonna paste my private SSH key. I just minimize this window for my private key to be safe. All right, join cluster and great, now the second node has joined the cluster. Note that if here you'll see an error, it's very likely that your firewall is blocking some traffic. Go ahead and look at our GitHub page for more details on firewall settings. All right, if I scroll down here, I can see more details about the nodes, how much RAM they have, their CPU, their Docker engine, and so on. All right, there is one thing we need to do after enabling Docker Registry. Remember how we said it's where our build is gonna get stored? Since when I pushed my app, Docker Registry wasn't around, I need to push it again in order for my app to get stored in Docker Registry. I only need to do this because previously Docker Registry wasn't available. But if you first enable Docker Registry and then push your app, you don't need to do this extra step. Anyways, I'll just upload my build. It'll take about a second or so because the image is already there. It just needs to get pushed to Docker Registry. That's great. It's pushed to Docker Registry. Now, the interesting part is that now if I click on the link, I'll open the app and I'll notice that every time I refresh, not only the name changes, but also the IP address, the public IP address of the app changes as well. It means that one instance of the app sits on the first machine and the second instance sits on the second machine. This is great. Now let's change our instance count to 4 and update it. And now my application is running in 4 different instances. And I don't need to do any sort of a specific routing, a specific load balancing. Everything happens for me under the hood. When I click on this link, there are 4 instances of the app. Some of them are sitting on the first node, some of them are sitting on the second node. And I can see that every time I refresh, I go to a new instance of the app. All right, let's go over what we have discussed in this video. we learned how to set up a Captain cluster and connect a root domain, how to create apps, deploy them using web interface and command line tool, enable HTTPS for Captain and for the apps, connect custom domains to the apps, change environmental variables specific to each app, scale apps easily by just changing their instance count. We also learned how to attach a new node so you will have a cluster of web servers. Finally, I have to say this again, Captain is not production ready yet. I made it to serve some of my side projects. On the plus side, as you saw, my goal was to hide the complexity behind an easy to understand, easy to work with interface. Yet, by using a not too intrusive approach to underlying systems such as Docker, Nginx, and Let's Encrypt, Captain allows the expert user to perform advanced actions that they might need, and those actions might not be available on Captain interface. Anyways, thanks a lot for watching. Let me know what features you want to see in Captain in our GitHub page or down in the comment section. Hope you guys liked this video. Thanks for watching and see you next time.